Okay, so today we're gonna be doing something a little different, and it's going to be proving the quadratic equation. However, it's with a little twist. So we're gonna have ax squared plus bx plus c equals 0. However, instead of me just showing you how to do this, we're gonna be doing it blindfolded. So I'm going to give you a little flashback to the good old days of 2020. Well, I'm going to be using a mask to cover my eyes because I don't have a blindfold. However, I wear glasses and my vision is completely dog water. I can't see anything at all when I have my glasses off, so it's kind of like double blindness because I can't really see that well out of just my vision alone. However, we'll be doing this blindfolded, so to make sure you guys think, the mask does a pretty good job blindfolding. You know. That's what you're gonna see. That's what I'm gonna see. So I'm just gonna be doing this blindfolded. So I put the mask on. I might look a little goofy, but I don't care. It's part of the challenge. Okay, so this is what it looks like. So I can't really see anything. So this could be like me, it's like the devil simulator. I'm just gonna have to do this blindfolded. So without further ado, let's do it. We're going to be proving this. We'll be proving the quadratic formula. Given we have ax squared plus bx plus c equals 0. Okay, so we're going to be using the standard method to prove the quadratic formula, which is using completing the square. Now, in order to get completing the square, we're gonna have to have two conditions. One, a has to be 1. 2, b has to be even. Now, b being even doesn't really matter. However, a being 1 does matter because we see in the ax squared, a is there, and we need to let a equal 1. So what I'm gonna do is I'm just going to divide everybody by a. I don't know where it is. So I'm just gonna divide everybody by a. It's like that. Okay? So when we do that, we see that this a and that a will cancel. So we're just going to have x plus bx over a. So we just have b over a x. And then we have our c over a. So plus c over a. And 0 over a is just going to be 0. Okay. So we see that we have this now. Alright? I can't really see anything. That's just the whole point. Okay, so we have x squared plus b over x plus c over a equals to 0. So now what I'm going to do is we're going to do the normal completing the square method. So I'm going to subtract c over a on both sides. So when we do that, we have x squared plus b over ax. I'm going to leave a space. It's going to be equal to negative c over a. Now, how do we get what I like to call it the magic number is what can make this side a perfect square. Well, in order to do that, I'm going to come over here and I'm going to let our b value, which is going to be b over a. So I'm going to bring b over a times we're going to multiply it by 1/2, and then we're going to square it. So we have b over a times 1/2 squared. So on the top we have b times 1, which is going to be b, so b squared. So we're going to have b squared, and then we're going to have a times 2, which is going to be 2a, and then square the first one, 4, square the second one, 4a squared. So we're going to have 4a squared, okay? That. So now we see that we have a b squared over 4a squared. So that's going to be our magic number, you can say. So we're going to add we're going to add b squared over 4a squared. And I'm going to add it over here, so 4b squared over 4a squared. Okay, so here on this side, now we have a perfect square trinomial. So here we're going to have x plus whatever is inside here. So we look back here and we see that we have our b over a times 1/2 squared. Look at the inside only. It's going to be b over 2a. So that's going to be inside our trinomial, and then we're going to square it. It's going to be equal to negative c over a plus b squared over 4a squared. So I'm going to come over here. I'm going to do a little bit of okay, so we have negative ca plus b squared over 4a squared. So what I'm going to do is I'm just going to multiply the negative c over a by 4a, top and bottom, and you'll see that this will just be 4a squared, this will just be 4a squared, so we're going to have a common denominator of 4a squared. However, we're going to have the top, which is 4ac, and then we have this b squared, and it's going to be a negative 4ac plus a b squared, so I'm going to reverse it using, thank you to the subtraction properties of numbers. It'll be b squared minus 4ac over 4a squared. So we're going to have b squared minus 4ac all over 4a squared. Okay, so now we have this equation. I think I'm running out of room. So here we see that we have a square. So to get rid of that square, I'm going to square root both sides plus and minus. So we're going to have x plus, oh shoot, what was here? B over 2a is equal to plus and minus the square root of b squared minus 4ac. And thank you to fractions and the square roots that happen to them. Square root of 4 is 2. Square root of a squared is going to be a. Lastly, we have this plus b over 2a. So that means that we can just subtract it on both sides. So lastly, when we subtract b over 2a on both sides, we see that there's a common denominator. So over here, we have our final step of x is equal, it's going to be the final answer is going to be a quadratic formula, so we just subtract it here. So obviously the final step is going to have x equals negative b plus and minus the square root of b squared minus 4ac all over 2a, and box the answer. So we just successfully proved the quadratic formula. Okay, so I think I did it. And the moment of truth, does this look wacky? Does it look goofy? Let's see. Wow, you can't even make out what I just did. That's the funny thing. What the heck? Oh my god, that's not even. Where did I write x equals? Oh, right here. Oh, can I be? Oh, okay. Wow, you can't even make it. Wow, that's okay. Wow, that's. Well, there you go. I proved it.